and I think it will address some of the conversations that we had yesterday afternoon about setting the scene, coming up with a higher scenario of what the problem is that semantic computing is trying to solve, what at a high level is the semantic computing, one or two case studies where we can specifically go through what the customer problem was and the solution. So what I just click on just an end. So what I've got here is it's a quick presentation. We want to just go through the high level, the business issues, and as discussed on a number of occasions yesterday, the key thing that semantic computing addresses is the growing issue of IoT and the growing issue of big data. And it's going to be doing that through a number of things, including data interoperability and putting context to the data that we're looking at within the data mining experience. Then I'm just going to do a high level of an introduction. And the reason why we thought we would do it this morning was that you now understand a lot more about each of the elements. And so by showing you the high level topology that we discussed with senior management, you'll know a lot more about it having gone through yesterday's session. And then finally, we discussed this quite regularly through the session yesterday. We want to try and just double check that you're on the same page with us and that you can move forward in conversations that you have with your own teams and your own management on the actual business benefits by looking at some of the case studies that have existed around the world, utilising a variety of solutions very similar to ours. So that's the three levels that I want to take you through. This session shouldn't take more than half an hour or so, except the fact that I won't go through this in huge detail, but I'm assuming everybody is completely across the concept of Internet of Things, and that it is been identified by a number of people as being one of the key technology trends that's going to affect the IT industry over the next 5 to 10 years. The issues that clearly it addresses are a variety of things, including the data storage, the requirement for unstructured data and data interoperability, because without those, the whole idea of the Internet of Things then just becomes conceptual. It becomes devices talking to devices, but if we're not doing anything specifically with the information we're getting, then we're really just collecting data. There are a number of high-level conversations going on at the moment in a variety of industries. For instance, have a guess how many devices are on that offshore oil rig that are collecting data at any minute, at any moment during the day. Any ideas?
Thousands?
1,000?
Several million?
Well, it's pretty close, but it's somewhere in the middle. There's 30,000 devices on that oil rig. Nearly all of them are just in the maintenance management for, is a pipe broken, so it's all high level, but it's very maintenance orientated, and there's only about 1 or 2% of the devices there that could be used by management to manage the output of the rig or manage key business decisions about the management of the rig. So there's a significant number of devices that aren't being used at all. Similarly, you would all know and love your bank, and you would be interested to know that less than 5% of the bank data being collected is actually related to assisting the clients. And so the Internet of Things, in a sense, is good, but what we want to try and make sure that if we're going to get some benefits out of Internet of Things, that it's actually the data that banks are collecting that can help us. And similarly, even in how, well, you're the perfect, you can tell us how integrated the data is in government, or even just how integrated the data is in the IP Australia. Fantastically not. Fantastically not, is the quote.
I think that's a common theme.
That's a common theme. And I think, and to a degree, it's all come from the legacy scenario of wanting to protect your own data silos, etc. But as we move forward, and hopefully with Paul Shetler's engagement, the ability to bring data together, the ability to integrate some data that's relevant to an outcome that citizens want or even government wants is really what you're trying to do. The second one that is also quite important is obviously all to do with the data mining, we've got big data, but many people refer to it as data tsunami, data lake, and when you think of the existing structured data becoming a data lake or a data tsunami, and then on top of that you then bring in your 30,000 devices contributed by IoT, then IoT plus big data is getting significantly adding to the issue. The one that is also coming out and is been highlighted is to a degree the complexity of some of the data analytics requirements, and that there is a huge gap growing between the growth of data and the actual growth of skilled people to be able to analyse that, so the data analytics. So one of the things that we're obviously spending a reasonable amount of time on is to try and make sure that a number of the data analytics tools that we take to market can actually be utilised by a lot less technical people, so that, which is why some of the interfaces we're spending some time on, is to allow end user managers and people that have the business problem to be starting to look at it, not having to rely on data scientists and data analytics specialists in everything we do. So that's also an issue. Now, if we look at the traditional data processing that is occurring in most organisations at the moment, we look at, you start with the structured data, there is a traditional data processing activity that goes on, produces a traditional database, in most cases the tools then that are utilising those traditional databases are available in the marketplace and are the standard data analytics tools that you can get from IBM, SAS and most other organisations. So that's a very structured approach, and that's what just about everybody's computing processing at a high level looks like at the moment. Another thing that most of you in the IT industry, especially the vendors, we all seem to hang off every word that Gartner talks about in this, the hype cycle of emerging technologies. Well, what's actually interesting here is, and I'll use my tongs.
It's near the glass if you want.
That's okay. I'll use these special technology tongs to highlight.
So emerging technology.
The emerging technology, the tongs. You'll notice that the big data has passed the peak of inflated expectation, and so obviously we aren't the only people that are starting to change the name of it, big data to data tsunami. And then when on top of that, then you start putting things like the Internet of Things, which is what they call the peak of inflated expectation. That is, it's going to be fantastic to everybody. The answer is it may not be, and if it compounds the data tsunami problem, then it's actually going to be drive both of them into the trough of disillusionment, and that's a very standard Gartner chart that you may not have seen, but what they do is they put all the technology and they try and link it to those. So over time, you'll see the bubbles that are on there changing positions within that curve. The curve itself remains the same. So if we look at the Internet of Things, for instance, just in isolation, a number of documents have come out over the last year or so. Probably the most important one was the Industrial Internet, which was highlighted by GE a year or so ago. And then in June this year, McKinsey came out with their own document, which was trying to identify and quantify the benefits of the Internet of Things. And as you'll see from the top, they're highlighting that the economic value created by the Internet of Things by 2020 could be up to $19 trillion. They've then broken it down into private and public, and then again they've then tried to break it down into specific industries. The difference between the low number, the 4 trillion and the 11 trillion, they've identified that those numbers are going to be massively affected by not just the Internet of Things, but the ability to use that data. So data analytics, data interoperability, all of those things will make the difference between the 4 and the 11 trillion. So what we are talking about isn't insignificant in its ability to create wealth and productivity in the world in the next 10 to 20 years. So we really are, those three elements, IoT, big data, and then cognitive and semantics and data mining as a group are actually critical to, well, I won't be esoteric here, and it's critical to society, but it's a very important element within the growth of the economies. Now, what we're also talking about is the ability not just to collect data, e.g. what is happening, but the ability to drive that data business analytics up the curve to starting to spend more time on the predictive elements. And that's why the semantic and cognitive computing becomes important, because you're now looking at like the demonstration we saw yesterday, you're looking at elements where you're starting to say, what if? How do these two entities interact, or what is the connection between these two entities without going in with a definitive formula or type process? You are actually you are starting with the what if, where it can be quite wide. So what we like, what we see, and this is a this is a Deloitte chart. So what Deloitte was identifying was that there are 4 boxes. It's related to data complexity and work complexity. And they've clearly identified that cognitive and semantic computing are up in the innovative model. That is, that these tools are going to be very good at where there is unstructured, high volume, volatile data, and that the requirements are much more about an unpredictable play, e.g. the what if, which is what we looked at yesterday. So you can see that what we're looking at the moment is trying to solve some key issues in the marketplace. Now, we've gone through this a number of times yesterday. The key elements to semantic computing is the interoperability of data formats, and then looking at the outcomes within the context of using a machine with the artificial intelligence and the semantic computing. And obviously this particular article went a bit wider than I, and identified that semantic computing can be affecting not only Internet of Things, big data, but obviously, you know, it will be driving the use of cloud computing, and clearly the collaborative social. And in a sense, the collaborative social are the contributors to the unstructured data anyway. So this is the sort of message we're explaining to senior managers in many organisations of why is this important and where does it sit. Now, a number of people have also asked what's the difference between cognitive and semantic, and here is a short definition. We see semantic computing as key within the arch of that Roman, the top of the arch within that Roman arch, in fact. So cognitive computing can be seen as that long. The semantic processing is the centre element, where all of the data is being collated and collected and put into a format that can be utilised by the data analytics tools. So to a degree, that's the reason why we're working with a lot of other organisations in the delivery of a total solution to the marketplace, because we don't preclude the use of traditional data mining tools that be available from HP and SAS, etc.
That definition of cognitive computing is basically a definition of how humans think anyway.
Oh, absolutely. Well, cognitive, that's right. I mean, cognitive computing is the cognitive thinking process. Now, what we've actually said, and that's a good point, what we've actually said, and a number of people have asked, artificial intelligence, cognitive computing, are you trying to replicate the human brain? And our answer is no, we don't need to do that. There are 7 billion people already out there. Our objective is to complement the human brain, to come up with a medical research assistant that can read the 70,000 research reports, and that can come up with short lists of initiatives that people can look at. At the end of the day, the researcher is still going to be making some of those decisions. So the computer is never going to overtake a researcher or a banking investment analyst. It's going to be providing the data to help them provide solutions to their particular project, hopefully faster and with more accuracy. So it's always, we see it as always the assistant, medical, financial, etc. Now, if I look at semantic computing or the semantic-based processing, yesterday we covered all of these topics at a high level. We're still talking about using professional users. We're obviously looking at the concept of the triple store with the data, templating the services to normalise the data sources, the ontology we discussed in detail. That's where all of the definitions of the data are. You can create your own, you can identify externals, you can merge, match, prune. All of these things are important. The semantic application, and then we're using the SQL query tool, report generator, and then obviously on top of that, you don't necessarily have to use the Sparkle query tool all the time. It's one of the tools. So if we now look at the diagram that I put before, this is the semantic interoperability platform, very similar to what you saw before, but obviously we've added some extra steps on there. We've added unstructured data, we've added the domain ontology that you can create, we've added your own ontologies, we've put the processor in place, we've come up with a number of tools that allow you to manipulate all of that activity. You end up, instead of just a normal database, you end up with a triple store, and then from the triple store you can then utilise traditional analytics tools, or you can utilise the Sparkle analytics tools. So it's not a massive increased change to what you're traditionally using. There are just a number of elements that you're actually fine-tuning and tweaking to allow you to allow the computer and to look at data in a far more contextual, and you're also allowing the computer to be collecting and utilising data from vast greater sources than it has in just the structured data environment. This is how we've broken it up, and so Bob might be showing you some tools, and obviously how we've broken it up is in a logical sense. We've got the ontology management suite. These are the tools that we've put in place that allow you to map, prune, etc. the ontologies. We've got the interoperability suite that works on the data and provides all of the data in the triple store, and then we've got the standard administrative and utility tools. So it's a reasonably structured approach, well, very structured approach. But not dramatically different to the traditional approach. I think Bob's already shown you this one. This is the ideas of the semantic computing applications, where they fit, what are the business problems that you could look at. This is a quite complex document, but I just want you to focus on, at the end of the day, we're not creating semantics for the fun of it. We're creating semantics to solve business problems. And if you looked at say a bank or a commercial organisation, their business problems are probably things like increasing revenue, deepening customer relationships, improving efficiency. And if you look at those, then your ability to work out the data sets that you need, the KPIs to measure my performance, are all very standard outcomes that you would have in any data analytics project. I'll just go through quickly A couple of examples. So here's an example in the UK. The UK Ordnance Survey Organisation obviously had the exact problem that we have. They had varieties of data sources that people had to mentally cross-match themselves or to buy all the ordnance maps and overlay it themselves. So what they were able to do is they integrated different maps from a diverse source of data. They developed specific ontologies for people to look at all of the terminologies. They loaded all of that information together, and then they made it available to specialists, and I think over time they're going to be making it available to the general public. And the advantage obviously was the data integration efficiency, utilising and repurposing data when you're able to overlay the topology of the land to electricity, plumbing, etc., etc. And obviously, as the infrastructure changes, what you actually want to make sure is that if somebody changes the piping in a street, we want to know that everybody knows where it is, or the electricity, or they take it underground. So that the benefits are very logical, that being able to look at a piece of land with everything that is affecting that piece of land, and a map is critical for people in project development of areas, etc. Another one which is slightly different is AGFA had a problem with, and it was just a particular one, of radiology procedures in remote locations. And what they needed to do is they needed to bring together data from a variety of sources, whether it be clinical guidelines to specific procedures to the outcomes of the radiology. And so they utilised a semantic processing to put it all into play, and then to make it available to people not only in the cities but also in the remote areas. So what you're trying to do is you're trying to get the people in the remote areas to be working and thinking the best of that group of radiologists, and in many cases probably the better groups were working in the cities. So it was creating a level playing field where they were eliminating as much of the procedural issues right across the world. Again, utilising the semantic. And the last one I think Bob's mentioned a couple of times is the BBC websites. There are a number of those where the actual website is the portal of a semantic processing system behind it, where they're collecting data from varieties of different sources, and they're providing it to the users, being people that are looking up the websites for, I think there's certainly one in the Olympics, there was one for the soccer, and there's now one for music. And obviously what the BBC is doing is they're hoping that by providing varieties of sources of data in the one website will increase the usage, repeat usage, etc., etc. So that's a very strong one, and you can look it up on the web yourself.
Just on that, that's a photo of Adele. She released a new album this week and went to #1 in 3 days.
And she's quite a traditional singer too. I'm amazed that it's rocketed through when I listen to some of the music my kids listen to. So that's the examples. And obviously we've also highlighted, just in government alone, areas that we think could be addressed in the use of semantic computing. Is to do with interaction with the public, which we're going to hear from Shetler next week. It's supporting the policy development by bringing different agencies together. Clearly national security and integrated at play, and we're actually talking to a couple of people about that already. And then the whole audit trail of whatever we're doing, let's make sure that we've overcome and adjusted to the risk, the governance of those activities. And then the last one, which is we've Bob also highlighted, was we've broken that down in government to a number of little sub-bullets where we've got some topics we can share with you on how that works. And that's it.